This is video FRQ1. Here's our problem. We have two tanks of water, and water is flowing into the tanks at different rates. You're given the function for the rate of tank A, and we'll skip over the unimportant part for part A. We're told that the tanks are initially empty. And so they're asking, well, how much water is in the tank at t equals 4.5? Okay, that's a quantity. This is a rate curve, and so the area under the rate curve will be the amount of water that we have in the tank. And here is how they write their solution. Okay, so for part A, they're looking for the area under the curve. What I really think you should do is just enter that curve as y1 in your calculator. So you can just use your integral function with y1 from 0 to 4.5. You get your answer. You don't need to write out all the decimal places. Okay? But the really important part here is reading their answer and how they score it. Okay, they're giving you 1 point just for setting up the integral, so make sure you show your work. Okay, the other is for a very clear answer. Note that they don't just say we have that many liters. Okay, they clearly say at this time the tank contains this many liters, and they round to 3 decimal places. All right, so part B. So continuing reading the problem, okay, we're told that we have a rate, an unknown curve as of now, of water flowing into tank B, and these curves intersect twice. One at time equals k hours, and the other they give you the time, 2.416. And in part B, they're asking, during the interval from 0 to k hours, water is flowing into the tank at a constant rate of 20.5 liters per hour. So note that that means that this segment here is a segment. It's not a curve. It's just a nice straight horizontal segment. Okay, and so these curves are intersecting when A is equal to that 20.5. And then they ask, what is the difference between the amount of water in tank A and the amount of water in tank B at that time, t equals k? Okay, so we're looking for a difference in amounts. Their answer, I'll show you, has 3 different parts. Okay, note how they're awarding points over here. Okay, the first thing you need to do is you need to find what k equals. Okay, and so you have a of k set as y1 in your calculator, and they want you to write down a of k equals 20.5, because that's the value of a when it intersects b. Okay, and so you would solve for that, set y1 equal to y2, and solve, and once again we find k, and so they're you're going to probably use k later in the problem, so I would use the store feature. So let's say I wanted to store this value in my calculator that I just randomly have here. That's not what k is. Okay, don't forget, all you do is you hit store, answer, and then pick a letter. And so I'll pick letter O. I'll just hit alpha O. And so anytime I hit O, like if I did 5 times O, I would get 5 times that value. And so it's a good idea to store that so you don't lop off a bunch of decimal places. All right, so continuing, there are different ways that you could do this. They set up this difference as one integral, which is great. Just realize you're finding the area under b, since b is the higher function, minus the area under a at that time. So it's this big area right here, which is just a rectangle. You didn't need to set it up as an integral. You could have just said 20.5 times k, which would have been the base of that rectangle. Okay, but what they did is they just said top area minus lower area from 0 to k. Note that you could use your integral function, and since you stored this in your calculator, you would just hit O or whatever letter you put there. I would recommend putting k. Okay, and so they want you to set up the integral. Okay, here's the answer you get with too many decimal places, but then once again, they're looking for a clearly written answer. And so right at t equals k, the difference, what they're asking for is this: use units and round to 3 decimal places. Okay, part C. Okay, so the area of the region bounded by the graphs of A and B, now from K to 2.416. And so if we look, that's this region here. Here, I'll just sketch it in. They're talking about this region right there. Okay, so the area of the region bounded by the graph. So that's the area between the two graphs. That's this region up here. Okay, and they tell you its value is 14.470. And somehow this should allow you to solve for the amount of water in tank B at that time of that second intersection. So what you're really finding is you're finding this complete area here, because that, since we start with 0, the area under B from 0 to 2.4, whatever it is, 2.416, will give you the amount of water in tank B. Okay, so I'll show you their solution, and I think it lacks clarity. I think it's easier to understand in this way. So go ahead and look at what they did. Okay, look at the 2 points you could get from this problem. But I think here is a more clear explanation of the problem. So what I did is this. I said the area under A from K to 2.416. And so that's this whole area of this big region right here, this big area, minus the area under B for that region, so that's minus this blank area down here, would give you the area you're looking for. And they tell you that that value is 14.470. Okay, so the area under A from K to 2.416 is a simple integral. Okay, the area under here, though, isn't so simple because we don't know the function B yet. Okay, but one thing we do know is this. We can break it up into 2 parts. Okay, the area under the curve from here to here would equal this whole area minus this little part over here. Okay, that would give you this area. And it's the whole area that we're looking for, if you remember what I said. Okay, and so that's what I've written here. The whole area minus that left part. And remember I told you that that left part is simply a rectangle? Okay, note that I use the idea that it's a rectangle by base times height for its area. And this integral right here is what we're looking for. The area, the amount of water from 0 to 2.416 in tank B. And the rest is simply algebra. Note that I left a lot of decimal places, and only in the end, I guess I would round my answer, and we can look at the way in which they wrote their answer correctly. So at time equals 2.416, tank B contains this, and note that they give you a little bit of leeway, but not much. So remember to use a bunch of decimal places in the store feature on your calculator, and then we use units again. Okay, part D. Okay, now for a later time. So after that intersection, from 2.7 to 4.5 hours, they give you the actual function now. Okay, so B is modeled by this function, and then they say, okay, is the difference in the amount of water, in the rate at which the water is coming in, increasing or decreasing? So think about this. This is simply a function right here. Okay, this function minus the function we had for A. And you're being asked, is this function increasing or sloping up, or is it decreasing or sloping down? This is a simple derivative problem. Okay, and so we can look at their answer. Okay, they're just deriving the function term by term. Okay, once again, this is a calculator problem. Okay, and they're evaluating it at t equals 3.5, what the question asked. And they found that it was negative, but notice that they included is less than 0. Okay, they want you to say it's decreasing by saying that this negative number, I know it sounds silly, but it's less than 0. So just be as clear as you can with your answers. Okay, and so here's 1 point for that, and then 1 point for your written out answer. The difference is simply decreasing at t equals 3.5. That's it.